Hello, welcome back to the course on audio signal processing for music applications. In this demonstration class, I want to go over Freesound but present some advanced features. We already talked about Freesound and hopefully many of you have used it and have enjoyed the great number of sounds that are there. But now I want to describe some more advanced features that are going to be quite useful for some of the things that you will have to do this week. So let's go to Freesound. And I guess you all know what it is. It's basically a community of people that are uploading and sharing sounds. There is a lot of people that benefit from it, but of course what is more valuable for Freesound are all the sounds and all the people that are contributing with information about the sounds they upload. And that's what I want to focus on now, is how to find all that information that users have been uploading and have been contributing with all these sounds and all these descriptions. So first let me go to the sounds page, and in here basically we see the recent sounds, and we see different ways of looking for sounds. Traditionally the normal way of searching for sounds is just the search and type some name of a sound, and then hopefully it will be found through there. But apart from that, there is other ways of browsing through sounds. Let's look at this area. These are different ways to browse of some data that users have uploaded. So for example, let's start with the tags. So with every sound, the users are requested to specify some tags that are meaningful for describing the sound. And these are the most common tags that people have been uploading. Okay, and we can start searching sounds through this tag cloud. So for example, a very common tag would be this multi-sample. Okay, so let's click at that. This is a tag that many people use to refer to collections of samples of sounds that people upload. So it's samples of a musical instrument, for example. Okay, so here we see a whole bunch of samples, and there is 12,000 samples. But let's say I want to restrict more and find some specific musical instruments. So for example, okay, there is this string instrument label or tag, and if we click at the plus sign, then we are adding these two tags. So we are adding the multi-sample plus the string instrument. And every time I do that, the tag cloud changes. So now, for example, it's showing all the tags that are found together with multi-sample and string instrument, and the size of the text refers to how many of those labels are actually used. So now with the multi-sample and string instrument, well, we see that the resulting sounds are from violin, or let's see, of viola or double bass or violoncello. So these are string instrument samples. So that's a pretty good way to search specific types of sound and narrow down the result to something that makes sense. So let's go back to the sounds. So now let's search through another type of information, like the geotags. So we can browse geotags. This is a type of tag that not all the sounds have. This is a type of tag that makes sense when a sound has been recorded in a particular geographical area, and that makes sense to reflect that particular location. So here now we see a map of the world, and we have clustered all the sounds for every particular area of the world, and we see how many sounds there are in those areas. So we can see that some areas have much fewer sounds than some others. So let's look at the one that has the most number of sounds. It's here in the middle. It has 4,700 sounds. So if we zoom in here, okay, now we go to this area that we had. Okay, so now the clustering is more fine-tuned. So we see that this area that has a lot of sounds is the area that not surprisingly is the area around Barcelona. So since we have been developing these and promoting it, so many people in our area are uploading sounds to Freesound. So that's good. So in fact, if we zoom even more, okay, we are going to zoom into the area of the city of Barcelona, and still there is a lot of sounds, right? So the city is all this whole area, but if we zoom even more, okay, now we will see all the sounds, the individual sounds that are actually identified. Okay, so this is all the individual sounds. And okay, there is an area that is very crowded. So in fact, if we zoom into that area even more, okay, this area, well, again, not surprisingly, this is the area where our campus is. So that means that all our students are really contributing and adding a geotag with the location of our campus. Okay, let's again go back to the sounds. Now let's use the standard search menu, search option, and let's just do an empty search. So let's just click return, caret return here, and it will show basically all the sounds that are right now in Freesound. And this is the total number of sounds that are there, so 224,000 sounds. So that's pretty good. We can find sounds from practically everything. And apart from that, it's also interesting to see the distribution of some of the characteristics of these sounds. So for example, we see the licenses that people have been using to upload sounds. There is the option of 3 types of licenses right now. Attribution, and that's the most popular one, and that means that you're free to do anything you want with the sounds here, but you have to give attribution to the owner of the sound. Another not so popular is the attribution non-commercial, so that means that you cannot use it for commercial applications. And finally, the Creative Commons 0, which is basically public domain. You can do anything, no need to attribute anything. And finally, there is this Sampling Plus that now it's not used, but this is a legacy license from some time ago that this license existed in Creative Commons and we used it. But also we can find like the distribution of tags, this tag cloud. We can find the distribution of file formats, sampling rates. So that's a quite interesting way to look at the whole collection of Freesound. Okay, now let's look for a particular sound. For example, let's look for clarinet. Okay, it's right here. So let's search for that. So this will return the sounds that either in the title of the name of the file or the description or of the tags, it has the word clarinet. So like this first one, it has it in the 3 places, in the title, the description, and the tag. So that's why it came up as kind of the first in this order list. Okay, and that's 900 and something sounds. But I want to look for a note of a clarinet, and this first has some phrases. So let's do advanced search. And for example, well, to make sure that it's a short, a single note one, so for example, let's just put that we just look for sounds that have a duration from 0 to 5. Okay, and now it will search for just within that for all the sounds that are only maximum of 5 seconds long. And this is what we obtained. So this is a little bit better, but still there is loops and things that's not what I wanted. So in fact, let's look at the tags, and we can add to that some further filters to narrow down the search. So for example, let's just look for single notes. This is a good tag here that should restrict to single notes. Maybe first let's take this out so that we see the list of all the sounds, and let's click here. Okay, and it got 255 sounds, and these are single notes of the clarinet sound, and we can play any of them. Okay, so this is a very high pitch sound. Then another way, once we have found a set of sounds that we might be interested in, it's good to use this option that is finding similar sounds. And this is the aspect that relates more to the kind of things we're doing in class and that we will be doing also in this week. So if we click find similar sounds, it will look through the whole collection of Freesound, not just the ones that are named clarinet. You will look through all of that for sound that have the same timbre quality. Okay, so this was our query sound, and well, not surprise again, the resulting sounds are also clarinet sounds because from the timbre is the most related one. But to understand that, I want to go to the demonstration, the place where the developer information is. Let's click here. So this is the page for the developer that wants to use the Freesound API. We'll talk about that in the programming lecture, but basically through the API we can use a software to access all the sounds and all the information and all the descriptors that have been analyzed for the sound. So in here we have the documentation, and we can go to the analysis documentation where all these analysis descriptors are listed. So these are the features that have been analyzed from the sound, from all the sounds of Freesound using Essentia, this library that again we'll be presenting in the programming lecture. And well, these are all the features that are part of the identification or characterization of the sounds, and from which then this similarity measure is established. So every of these features have several values that describe this sound, and then we can measure the distance between every two sounds from this data. Okay. For example, if we go to some of them in particular, we can see how the information looks like. Well, the information is in the Essentia website, where the information about how this feature has been computed. Here what we see is in fact how to actually through the API access this information, the detail of it, and the actual details of what has been computed. So what we have access is not every single MFCC coefficient for the whole duration of the sound, but to the statistics of this feature for the whole duration of the sound. So here we see the minimum and the maximum, variance, etc. And here we see an histogram of the distribution of values for one of these particular coefficients, the coefficient 0, for the whole collection of sounds in Freesound. So basically that means that all the sounds are quite well distributed in terms of this coefficient around a certain value. If we look at other coefficients, they are more symmetric, so the distribution is more Gaussian, so they are better distributed. Okay. So anyway, so through these descriptors, now we can understand a little bit better what this similarity does. So let's go back to the main sound page. Okay, and now let's search for another sound. Let's, for example, search for the sound of rain. These will return the sounds that have in their name the word rain, either in the title or in the description or tags, and order by so in this first one, rain is in the 3 places, so it's ranked first. This first sound is this sound. Okay, so it's a heavy rain. Now, if we search for similar sounds based on this similarity, on comparing all these features of the sound and finding the closest ones, okay, the query sound was the one we just heard, and the first return sound is also the sound of rain. It's very similar. But what is interesting is that the third closest sound is not the sound of rain. In fact, the name rain is not in the title, nor in the description, nor in the tags. It's the sound of waterfalls. Let's listen to that. Okay, so this is sound from a waterfall, but it sounds very similar to the sound of rain. So this is why, through this content description, independently of the tags or the textual information, we have been able to find these relationships. This sound, by the way, has a geotag, so this is the label of the geotag. So in fact, if we click there, it will show the map where it got it from or where it was recorded. The user specified the recording location, and I guess this is the Bahamas. So yeah, this is Florida, and this is definitely the Bahamas. Okay, now let's go back to here. This is my home page, basically, where all the sounds I have been uploading are gathered. And I want to talk about something that I have been specifying for some of the sounds I've been uploading. Okay, so for example, let's look at this sound of the speech male residual that I uploaded as an example of the harmonic plus residual analysis. Let's listen to it.
Do you hear me? They don't lie at all.
Okay, this sound is a sound that I obtained analyzing the speech male sound. So what I did was to specify this relationship, and this is captured by this icon. So the remixes relationships. This is the remix tree. Okay, so the sound that I clicked was this speech male sound, and what here it tells me is that this sound is related to the speech male sound. That basically the source of our sound is the speech male sound. And I also specify all these other sounds that I generated, and I specified that they come from this speech male sound. But in fact, this speech male sound is also not an original sound. It's a sound that I obtained from another sound in Freesound, from another user who has been uploading great sounds. And I just cut a section of it, I converted to mono so that it could be useful for the class. But I made explicit this relationship. Okay, and this is very good because this is a way to keep track of all these relationships. And that's all I wanted to say. Basically, we went through some advanced features. Hopefully you became motivated to use Freesound, and especially to contribute to Freesound. Freesound is as valuable as the community around it is, and therefore their contributions and how valuable are their effort in contributing to that. So let's go back to here, and well, we went over Freesound, and we looked at this documentation from the API that we will look more carefully in the next programming class, that explains how these features of the sound were analyzed, and therefore allows us to understand better some of the features of the similarity search in Freesound. And that's all. We went over some advanced features of Freesound. There is much more that we could talk about, but hopefully with that you have enough information to understand some of the things that you will need, especially in the assignment of this week. And hopefully this has been useful for you. So thank you very much, and I see you next class. Bye.